Hello students, I'm back with new video on ellipse to discuss uncovered important portion. I'm sure that you are done with ellipse part 1. If not, then go through that one. The link is in the description box. As I already discussed with you two types of equation of tangents, and those are equation of tangent in slope form, where we use condition of tangency, and equation is y is equal to mx plus root of a square m square plus b square. And second equation of tangent in point form, where using the point x1 y1 we just put and find t0 using equation of ellipse. That is, t0 is here, xx1 we are doing on ellipse, so this comes out to be xx1 upon a square plus yy1 upon b square equal to 1. So this is what equation of tangent in point form, equation of tangent in slope form. There is one more form, and that is equation of tangent in parametric form, where the equation of tangent to the ellipse is at the point a cos phi b sin phi, or a cos theta b sin theta, where theta is known as eccentric angle, is x by a cos phi y by b sin phi is equal to 1. This is what just we have done. T0, instead at x1 y1 we did t0 at a cos phi b sin phi. Now look how I have done this. So equation of tangent in parametric form, we have to put t0 at a cos theta b sin theta on the ellipse. So here instead of x1 I put here a cos theta, and here I put b sin theta. So my equation turned out to be x a cos theta upon a square, y b sin theta upon b square. On further solving, we get x by a cos theta plus y by b sin theta equal to 1. So this is my equation of tangent in parametric form. This form we usually use in case if we have to get the equation of locus. Now here, one more thing, in case of ellipse, if you have to find any tangent, so in that case we have two tangents which are visible, and those we have four tangents which are visible, and those four tangents are, if this is my ellipse, so this point is a0, this is minus a0, this point is 0b, and this is 0 comma minus b. So four tangents which we can see are, one is at this end of major axis, another is this tangent is x equal to a, we can let, and this is x equal to minus a, and two more tangents, and those are at the ends of minor axis. This one is y is equal to b, and this one is y is equal to minus b. So if we get question on any tangent, so we can assume any one of these four tangent in that case, like in this question. The tangent at any point on the ellipse 16x square plus 25y square is equal to 400 meets the tangents at the ends of major axis at t1 and t2. The circle t1, t2 as diameter passes through. One more thing, if extremities of diameter are given, that means the end points of diameters are given. That means if x1, y1 and x2, y2 are the ends of diameter, then equation of circle using these 2 points is x minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0. So in this particular question, First, we just convert this into standard form. That means we just divide left hand side by 400 so that we get the standard equation of ellipse. So here I get 25 and here I get 16. So my ellipse is now x square by 25 plus y square by 16 equal to 1. So my a is here, a square is here 25 and b square is here 16. So this point on diagram is a and that is a0. Since a square is equal to 25, so a is equal to plus minus 5. So my one of the end of this major axis is 50 and this end is a dash, that is minus 50. Same here, if b square is equal to 16, then b is equal to plus minus 4. So my two ends of minor axis are b and b dash, and those are 0, 4 and 0 comma minus 4. Now, what is given in the question? The tangent at any point on the ellipse this meets the tangent at the ends of major axis. So two tangents at the end of major axis are these two. This drawn by red lines. So this tangent is x equal to 5. That is a line parallel to y-axis perpendicular to x-axis. X is equal to constant. And this is another tangent on the another end of major axis, and this tangent is x equal to minus 5. So we have to draw two tangents at the ends of major axis. And we have to draw one more tangent, the tangent at any point on the ellipse. So we can take that tangent as y is equal to 4, which is drawn by this green line. Now T1, T2 are the point of intersection of these three tangents. That means the point of intersection of x equal to 5 and y is equal to 4 is the point T1, and that is 5 comma 4, since x equal to 5 here and y is equal to 4 here. So this is T1. Now T2 is the another end, and that is, since x equal to minus 5 and y is equal to 4, so this point is minus 5 comma 4. Now what we have to do, we have to draw a circle taking this T1, T2 as the diameter. So now this is my circle, which is drawn by taking these T1 and T2 are the extremities of diameter. As I have already written here, that if ends of diameters are given, then equation of tangent is x minus x1 into x minus x2 plus y minus y1 into y minus y2. And now my ends of diameter are minus 5 comma 4 and 5 comma 4. So my equation of circle comes out to be x minus 5 into x plus 5 plus y minus 4 into y minus 4. Now further, what we have to find in this particular question, we have to find the circle is passing through one of the following these four options. So just we have to satisfy the option, and as I put the first option, that is 3, 0. So what I get if I put here 3, 0, so I put x equal to 3 and y is equal to 0. So my answer is here, this is minus 2 into 8 and this is minus 4 into minus, that is plus 16. So this point satisfies the equation, therefore this is the correct option. But we have to check all the three options also. We have to check all the four options. So after checking those three options, then only we just take the option number A is the correct option. Now next, another application. Now in this type of question, if the tangents are drawn to the ellipse x square plus 2y square is equal to 2 at all points on the ellipse other than its four vertices. So we cannot take any tangent at the ends of major axis or at the ends of minor axis. That means out of these four tangents, we cannot take any one because it is written here at all points on the ellipse other than four vertices. then the midpoints of the tangents intercepted between the coordinate axes lie on the curve. So since this question is of locus, we have to find the locus, that is the curve. So we have to assume the tangent in parametric forms. For that, I have to take point in parametric form. So let that point be A cos theta, B sin theta. Now, equation of ellipse is given to us here, x square plus 2y square is equal to 2. So first we convert it into standard form. So this comes out to be x square by 2 and y square by 1 equal to 1. So in this case, my a square is 2 and my b square is here 1. So now this point turned out to be root 2 cos theta and 1 into sin theta, that is sin theta. Now we have to find equation of tangent at P. So equation of tangent in parametric form is T0. That means we have to put T0 at root 2 cos theta, comma sin theta on this ellipse, x square by 2, y square by 1 equal to 1. So my equation comes out to be root 2 cos theta x square by 2 and y1, that is sin theta y upon 1, and further I just convert this line, this is x1, so this is only x, root 2 cos theta into x. Now I just convert this line into intercept form since I have to find the points on x and y axis. So intercept form is x by a, y by b. So in this case, my intercept form is this. On further solving, I just write this as x upon root 2 by cos theta and y upon 1 by sin theta. So this will be my A of line and this will be my B, that is the y-intercept of line. So now this point comes out to be root 2 by cos theta, comma 0, and this point on y-axis is 0, comma 1 by sin theta. Now what else I have to find? We have to find the midpoint. We have to find the locus of midpoints of the tangent intercepted between the coordinate axes. That means the midpoint of AB, locus of midpoint of AB. Let that point be R, x, comma, y. Now just I have to follow the given condition, and that condition is the locus is the midpoint of A, that is root 2 by cos theta, comma 0, and B 0, comma 1 by sin theta, and R is the midpoint. So we apply the midpoint formula. After using the given condition and eliminating theta, we get the locus. So the midpoint formula is here root 2 cos theta plus 0 upon 2 is x coordinate of R, and 0 plus 1 by sin theta upon 2 is equal to y is the midpoint formula on y coordinate. Now rest, what I have to do, I have to eliminate theta, because eliminating theta, after eliminating theta we get the locus, that is the equation of curve. So how I obtain that? This is equal to x, and here I get 1 by 2 sin theta equal to y. On further solving, I can just write this as x upon root 2 cos theta is equal to x, and y upon 1 upon 1 by root 1 upon root 2 cos theta is equal to x, and 1 upon 2 sin theta is equal to y. Just change the sides, and from here I get 1 upon root 2x is equal to cos theta, and 1 upon 2y, just interchange these two, is equal to sin theta. And now after squaring and adding these two equations, theta gets eliminated, so we get the locus. So squaring 1 and squaring 2 and then adding. So here I get 1 by 2x square and here I get 1 by 4y square, and on RHS I get cos square theta plus sin square theta. So that is 1. So this is my equation of curve, and my correct option is here, option D. So this is the application of parametric form, equation of tangent in parametric form. Now next, these are definition of ellipse, which is very important concept. Now, first definition, we have two definitions, and first definition is written here. An ellipse is the locus of point, or we can just here, what is written here? An ellipse is the locus of point on a plane which moves in such a way so that its distance from fixed point, that is focus, in the same plane to its distance from fixed straight line, that is directrix, is always constant, which is always less than unity. Or in other word, we can say that SP upon PM is equal to E, where SP is the distance, S is here focus, and P is here moving point XY. And according to definition, the locus of ellipse is the locus of point P, which moves in such a way so that the distance of this point from focus. So this is SP. In diagram, this is SP, distance between focus and a moving point. And there is a straight line which is known as fixed line directrix. So this is fixed line. So according to definition, ellipse is the locus of point which moves in such a way so the distance of this moving point from focus, that is SP, to its distance from moving line, that is directrix, and the distance between point and line is AX1. The formula is AX1 plus BY1 plus C upon root of A square plus B square, that is distance of a point from a line. So SP upon PM, the point is moving in such a way so the distance of this moving point from focus to its distance from directrix is always constant, and that constant is always less than 1. So SP upon PM is always constant, and that constant is less than 1. And this constant is known as eccentricity, and eccentricity of ellipse is always in between 0 and 1. So this is what SP upon PM is always constant. Suppose that constant always comes out to be 2 by 3. So in that case, the locus of point is ellipse. Point is moving in such a way so that distance from fixed point to its distance from fixed line is always constant, and that constant is always less than 1. Then the path traced by moving point is ellipse. Now how we use this? There is an example written here. Find the equation of ellipse whose focus is 1, 0. That means S is here 1, 0. And the directrix is here x plus y plus 1 equal to 0. And eccentricity is equal to 1 by root 2. So in this case, we have to find the locus. So we use the definition, and that is SP upon PM is equal to E. So S is here focus, that is 1, 0. P is here moving point, and SP is what distance formula between these 2 points, that is x minus 1 whole square plus y minus 0 whole square whole under root. If SP is equal to EPM, then SP square is equal to E square PM square. And this is what the square of distance formula between xy and 1, 0. And in place of E square, I just write 1 by root 2 whole square. And in place of PM square, what I have done is the distance of a point P from the line x plus y equal to 1. So that is AX1, 1 into x, BY1, 1 into y, plus C, 1 into x plus 1 into y plus C upon root of 1 square, that is the coefficient of x plus coefficient of y square, 1 square plus 1 square. And after solving this, we obtain an equation, and this equation is ellipse. This equation is second degree equation of ellipse, and the standard form is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. So we have used the definition to find the equation of ellipse. Now next, how we use this? Now, in this question, equation is given to us, and what they said that this equation represent an ellipse, and we have to find A belongs to one of the four options. So if this is the equation of an ellipse, then this must satisfy the definition of ellipse, and as we know, definition is SP is equal to EPM, or SP square is equal to E square PM square, and here 13x minus 1 whole square plus 13y minus 2 whole square is equal to a square minus 2a plus 1, and pm square is here 5x plus 12y minus 1 whole square. Now I'm just rewriting this equation. If I take 13 common from this bracket, I get 13 square common here. If I take 13 again common from the second bracket, I get 13 square common from both the brackets. So I have written here 13 square, and within this bracket, what I have, x minus 1 by 13 whole square, and here y minus 2 by 13 whole square. Now, I can just rewrite this equation as a minus 1 whole square, because this is an identity a square plus 1 minus 2a. And just I am rewriting this 5x plus 12y minus 1 whole square. Now, if I take this 13 to RHS, so this comes out to be like this. And I take this 13 square as the denominator of this equation. So I can write this. This is my 13 square. Now, again, I am rewriting this. And you can write this 13, this is what 13 square, and we can write this 13 square as 5 square plus 12 square, because this is 13 square. Now what I get from here, this part comes out to be SP square. You can check. So this comes out to be E square, and this part comes out to be PM square. How? We can check this. This SP square is the square of the distance formula between S is here 1 by 13 comma 2 by 13. P is here x comma y. So as we can see here, this is the whole square of distance formula between x, y and 1 by 13 comma 2 by 13. So my E square is here a minus 1 whole square, because this is at the place of E square. And we can further check that this 5x plus 12y minus 1 whole square is what the distance between px comma y moving point and the directrix 5x plus 2y minus 1. We can write distance of a point as 5 into x, 5x, 12 into y minus 1 upon root of a square plus b square. Since here I have square, so I just eliminate root and I write this as 15 square, 5 square plus 12 square, that is 13 square. So this part is my PM square. So what I get from here, if E square is equal to a minus 1 whole square, then E is equal to a minus 1. And as we know, the eccentricity of ellipse is in between 0 and 1. So I just replace this E by a minus 1. And if I add 1 throughout, so what I get? 1, and my A lies in between 1 to 2. So A belongs to open into 1 to 2. So my correct option is here, option C. Now next is written another definition of ellipse, which is more important. An ellipse is the locus of a point which moves in such a way that the sum of its distances from two fixed points, that means those two foci, is always constant. How we just, here what is written? SP plus S dash P, that is the distance of a moving, sum of its distance from two fixed point. One fixed point is this focus and another is S dash. So SP plus S dash are two focal distances, and those are A minus EX plus A plus EX, and hence we get 2A. So my definition is in ellipse is the locus of a point which moves in such a way so that the sum of its distances from two fixed points is always constant, and that constant is always length of major axis. As you can see here, what we get, SP plus S dash P is 2A. So this constant is always length of major axis. Now application of this second definition is here. What is given in this question? Px comma y, f1 is 30, f2 is minus 30, and this is my ellipse, and then we have to find pf1 plus pf2. So first I just reduce this ellipse into standard form and check the focus. So this comes out to be, if I divide this by 400, so my ellipse is x square by 25, y square by 16 equal to 1. That means my a square is here 25 and my b square is here 16. And the foci is AE is equal to root of a square minus b square. So this is my f, and this is my f1, this is my f2, and p is here. So AE is equal to 25 minus 16, that is root 9, and AE comes out to be plus minus 3. Yes, these f1 and f2 are two foci which are given in the question. So since these are two foci, so this is the second definition of ellipse, that PF plus PF dash is always constant, and that constant is length of major axis, and A in this question is 5. So my answer is here 10, that is the C option. So I'm sure these two videos on ellipse will help you to crack the question. I'll be back with new video. I'll catch you guys very soon. Please like and share my videos and subscribe my channel method wise. Thank you.